Hello everyone. Today we're going to see about second experiment, feature selection and feature extraction. I have used libraries, pandas, numpy, fill import image. It is used for image processing. Then matplotlib, sklan features, kbust and site2 for feature selection. Then virtual info regression for information calculation. Then linear discrimination analysis used for LD feature extraction. Here I am reading the data set wine equality features.csv. Second question, dropping chlorides and free sulfur dioxide column. Here I am dropping uh, these two columns, chlorides and the free sulfur column. Axis equal to 1 means column wise. Then question number 3, identifying the numerical column with outlier, displaying it, dropping the column and display the size. To detect an outlier in a column using IQR. Here I am copying the data set in temporary. Then using for loop to only for numerical columns, include equal to number. Then finding the 25th percentile and 75th percentile. It is Q1 and it is Q3. I have used formula IQR equal to Q3 minus Q1. If temperature of diff column less than Q1 minus 1.5 E. Then I am adding the column to the list if outlier exists. Then dropping all column containing outliers. And question number 4, identifying the numerical column with variance less than 0.5 and then displaying it, drop the column variance less than 0.5. By computing the variance of all columns, selecting the columns with variance less than 0.5, then dropping the low variance column. Then fifth question, identifying the input column with less than 0.1 correlation with the target column quality and displaying it. Here I have used the correlation matrix and taking the correlation with quality. Then apps of it is used to calculate the absolute value. Selecting the column with correlation less than 0.1. Question number 6. Dropping the column with 0.1 correlation, displaying size using temporary data frame and here I am getting the column names, then dropping them. Seventh question, identifying the pair of highly correlated input feature with correlation greater than 65%. Here I am removing the target column quality when computing the correlation among the input features using a nested loop to compare the pairs. If correlation less than 0.65, printing as highly correlated pairs. And eighth question, dropping one feature from the highly correlated feature pair based on its correlation with the target feature quality. It is a feature to feature correlation, then feature to target correlation if highly correlated. Then dropping the one with lower correlation with the target. Question number 9. Separating the input features X and target feature Y from the data frame. Here Y equal to quality, then print defining the input and target column, then extracting the column from the data frame. 10th question, perform univariate feature selection using select k based from k-kit library with the score function is ch2 and k equal to 5. Yes, selecting the top five features and selecting top five features and site two. This is for scoring function. Then fitting the model and transforming the data. Then return selected feature mask. 11th question, estimating the mutual information score for input feature to target quality and displaying the input feature which are highest mutual information with the target. Uh, Here I am computing the MS score between X and Y, then converting into series X dot columns, then returning the features with highest MA features. 12th question. Performing a feature extraction using PCA by step-by-step Python code. I am taking first two principal components. Here I am converting the data frame into NumPy array. Then X data minus NP dot mean of equal. This we read the mean centering. Then covariance matrix. Then calculating eigenvalues and eigenvectors. Then I am sorting the eigenvalues in descending order. Descending order. Then I am selecting the first two components and project data into new components. The 13th question, performing feature extraction using LDA with a KKit land library, taking two LDA components. Here I am creating LDA model, linear discriminator analysis, n component equal to 2. Then fitting and transform the data and convert Y to 1D array. Then 14th question, reading an image delta.bmp, extract the pixel by pixel mean feature then displaying it. Here I am reading the image, then getting dimension by using row column channels equal to image.shapeout. Then using gray to create a empty grayscale matrix. Then using loop to loop through every pixels. Then extracting RGB values. Then computing pixel mean as a grayscale matrix. Then displaying the grayscale image. Thank you.